Like it's now my audible or it's still breaking? Let me know. Am I still audible? It's still Am I still audible? It's still breaking. I don't know what's happening. Mic check, mic check. Now I'm audible. I hope so. My screen is visible to all. Let me know on the chat. My audio is cutting right now. Let me see. Um, Still don't know what's happening. Still sure. I feel like I'm not able to understand what's happening again. Is it still like a cracking kind of thing? Let me know. Otherwise, I will refresh the whole system then. Still getting what's happening. Uh, I think it's okay. And just have a double check. Okay, or like, or is my voice only? Let me do one thing. Yes, this makes better most probably. Now it's better or a little cracking and all. Cool. Great. Start करते हैं. ठीक है. Sorry folks for so much crack and all thing. Let me know if I am cracking at any moment. I will like kind of retrain it like again and again. No worries at all. So yeah, thanks Subsal for making the whole stream and all. Those who are facing issues, they can rewatch the stream. That's that will be good, I guess. Cool. And let's start off it. So today we'll talk about like that's our topic about speed engineering and performance. Basically, there will be no code for this session. It's totally theoretical. Theoretical in terms of practical sense also. Basically, I will talk about how you improve your model, what is metrics, what is feature engineering, what is variance and bias kind of thing, like bias necessary kind of thing. So we will talk around it. Okay. And I doesn't take much time, but let's take it out my pen and palette for basically explaining you all in that. So give me a moment for that. And let's do the Excel basically. Basically the thing where I'm also cool. I guess it's yeah. I guess it's more like a pencil thing, majorly of that thing. Let me, let me erase it. Okay, and let me get back to okay. Yeah, important thing that let me go to the thing. Okay, so I hope so. I'm again hoping you can say okay, its voice is not clear. I'm not getting why it's happening. I don't know why it's happening. Let me do one thing. Let me join from if that possible and kind of do one thing. Give me a moment. Give me a moment.
There is a problem while doing it. I'm not able to screen share it. Give me a moment to solve it. Just give me a My voice is clear, but actually I'm not able to because I'm on from a phone, so maybe I'm not able to directly share it, screen share it from my phone actually. So give me a moment. Let me do. Okay, what I can do, maybe I will try to do something from my phone. Let me know if it is visible to all of you or not. I will try it for first time. Still my laptop is kind of rebooting. Okay. Still I guess my voice is clear, right? Let me know. Like or it's still breaking in some way. Let me know that. I hope so. It's clear. Cool. Let me check on my chat. Yeah, it's clear. Okay, so I'm on my phone. Okay, I don't know why my laptop is doing something weird stuff like this. Okay, so let me share my screen then to give you more better. Okay, so hope so. My screen is visible to all of you here, and let me make it this. Okay, okay, cool. Or maybe it, like how it's better to for you to basically do it. Let me make it. Okay, cool. Let me do something from this only. Okay, so cool and cool. I guess that will be better for you now. Okay, so let's go more on like a basic thing. How basically what is actually like my major focus is to basically give you more internal insights around. You can say how to treat a data. And first of all, because data is very important while you are building any of your, you can say, model, you can say machine learning model, right? So generally the let me make it more um, the time trying. Let me. Okay, so So this is a basic formula. If you pretty much know, I don't know how it will show. W is equal to W minus, or you can say W naught minus alpha. That is the learning rate. And basically, I'm hoping ki like this stuff actually tell you already, because we already did same something like that. And let me know if it is not divided by yep. If you will go, so this is kind of, let me select it more like in this format. Okay, so something like this, if you will see. Okay, so this is a basic, this is the basic formula of, you can say, like gradient descent basically. Okay, so same thing for the weight, and same like this is for the weight, and this is other for the weight, you can say. I'm hoping, I hope so, you got like this is the basic formula of gradient descent. You can do same thing with, you can say, let me show you in more like with the weight or with the bias. You can say v is equal to v naught minus alpha, differentiation of, you can say, loss function, where we double by b, we are differentiating that thing with b basically. That's a relative, that on which relative you are basically trying to do. So this is the way. And majorly, if you will see here, majorly if you will see here, or like let me go here, and this part, this part basically is slope actually. Yeah, this is the slope. Okay, and why, what is the necessity behind it, I am not going into the mathematics of that basically for now. Okay, but let me clear this stuff. Okay, let me clear this stuff. Okay, okay, cool. Now the major thing that we wanted to discuss today is more, or like you can say, what is uh, variance and bias. Okay, actually I actually explain those if those who pretty much know about the bias and the biasing thing basically. My major focus around how you basically understand this model is good or bad. Okay, sometime it's happened like sometime, or like majorly time, you got your model 100% accuracy, right? That's not the case actually. This is not good thing, because it's not possible to get 100% accuracy. There's a higher possibility your data is underfitting basically, or you can say you're not underfitting. That will be the overfitting, you can say. What is the meaning of overfitting is basically think or more like um, how I can explain you with that basically. So think in more that way, like there is a lot of data, and for testing time when you're testing, because how we predict that thing, we have some test data, and on that basically test data we are kind of predicting the other stuff, right? So generally it can possible the training, the test data that you are having have a same kind of data in training also. So it's overfit the data. That means the training data is also have a same something like the test data that you're testing for that, right? So that's the main thing in around this. That's what over underfitting, sorry, overfitting basically. And what is the meaning of underfitting, right? You have a very less of data, so that he can't able to learn at all. That model not able to learn. So maybe it can goes to the accuracy of less than 0% also. Like that's the basic thing around it, right? I hope so. Still, everything is goes clear. Let me check. Is everything is going great? Or let me check the. I hope so. It's still what I explained you till now. It's I hope so. You're getting okay. Cool. Now the major take behind everything this is that let me give you more broader view, you can say. So Lo- okay, just give me a moment. Let me do one thing for you all, just to give you a better understanding. Just give me a moment. Just give me a moment. I guess from my laptop it will be better because in phone it's very difficult for me to understand. You just give me a moment. Okay, I'm testing another setup thing. Let me know my voice is clear or not. Just give me a moment. I'm just checking one thing, okay? And let me know if it's going through or not. Okay, just give me a moment.
Now tell me, I am audible now, or it's clear or not? Just give me a more. Just give me like in a chat or something like that. Let me know. Am I audible, or it's still cracking? Cool, great. Thanks, Asmi. Okay, now I guess I am hoping I can do my thing better. Hoping. So let me share my screen. Now it's better for me to. I can restart same thing so that you give you a better understanding about the model performance and all. So let me share my screen and give me a moment. Yeah, I guess. And let me know while sharing, is it still cracking? My screen is visible and my voice is also audible. Let me know first of all. Tell me that. Let me open my chat on a side thing, that will be better, I guess. Voice is audible and my screen is also visible. Let me know first that. Great. Let's start with it. Okay. What I did basically, I basically from my Chrome, I directly shifted to desktop app of Discord. So that's generally what the what we have to do around it. Okay. So okay, cool. Let's doesn't take much my time, and I will start this off. Cool. Okay. Let's start from very starting. Okay. So understand. Uh, Today we will majorly I will talk about the model performance. Okay. So today we will talk about this is very bad, I guess. I have to come with you can see this thing. Okay. And yeah, so today we will majorly focus on the model. Okay. Now the major thing, how to decide this model is good or bad. Okay, that's the first and foremost thing, right? How we can do it. So suppose your data, you have an Excel sheet data, or you can say you have a CSV file, suppose. And suppose you do your matplotlib, or you are plotting that particular data. And suppose this is something kind of data. Okay, and this is, you can assume this is cat versus dog probability ratio graph, you can say. Okay, something like this. Okay, so suppose this is the kind of data, right? This is the plot that you did. And when we say overfitting or underfitting, so suppose the question in this graph is to just focus on the thing of cat, what is cat and what is dog. We have to basically classify it's cat or a dog, or you can say cat or non-cat. Let's go with that thing, that will be better, I guess. We have to go with the thing called cat versus no cat, non-cat, I guess. That will be better. Okay, non-cat. Okay, now as a normal human being, we can know like this is obviously a cross. Okay, so we have to find the, like that's what the concept behind the activation function came into place. Okay, so first of all, normal thing, anyone, if we go linear, this is maybe we can say this is cat and this is non-cat. But the point is, if you will see here, let me change my color here, stroke. This part we left, right? And this part we left. This is not we can do. Okay, so let me, when we say activation function, what actually its mean is, when we say activation function, okay, what actually it shows this part. If there is a mathematical function which basically do something like this is what we got. This is, but the point here is, this is too much accurate. This is some it's not possible some data in a airspace, and this kind of function that's called, that's we like, which giving you 100% accuracy. There is nothing like, you can build obviously some function around it, but obviously that activation fun, like how you understand, for this kind of data you get this kind of activation function. You can consider activation function like ReLU function, softmax function, or you can say maybe 10h function, something like that. Okay. Those who don't know 10h, it's something like, if I am not wrong, just give me a moment, e to the power x plus e to the power minus x divided by e to the power x minus e to the power minus x. Maybe it's opposite, maybe it can be reciprocal, but something like this. This is a 10h graph, right? 10h, you can say, function around it. But before getting into this, my major point is how I can basically solve this part, like how I make it more better. So here it's you can say overfitting. Why I'm saying overfitting here means, the major thing that I wanted to understand here is like how I can make something which is not. So what I mean to say here is, suppose we have some tabular data, okay, like maybe your name. Let me write in a JSON format here, okay. So let me write a form of code, maybe how I can write it, maybe this, okay. So suppose, let me make it more, let me write a code in that format, okay. So this is one is name, okay. You have something name, maybe here, let me go to the Asmi for now, okay. And okay, next name, next thing maybe class, suppose, or some, to be very precise, okay. Here we can write, or if we can give a numerical value 3, okay. uh, what I can write, maybe tfug member. So this can be boolean, maybe for, maybe true, maybe like so. What I wanted to share is you is like, if you will, see this, and let me expand it to you, okay. This is one structure of data. Something, same thing can be do it like many times, like this is Asmi, maybe for other folks, maybe for Afzal, for same thing with Galactus, like I can create a data around it, right? But my major point is here is how I can finally decide for which feature I have to choose. Like, that's what called feature engineering came into play, right? Suppose for let me understand this part, maybe through here, okay. So let me first of all remove this thing, that will be better, okay. And let me do a tabular thing to get you better understand, okay. So this is one tabular thing, and let me mark, okay, for this, okay. So understand, basically we're trying to understand how a tabular data works around it, okay. Let me go here, okay, and let me do an arrow thing for better, okay. So this is one line, okay. Okay, so, suppose this is the major thing, okay. Now first one is about the name, second one is about the semester, and third one about the member, you can say, okay. Now the major thing is, there's a lot of data. There is a possibility for the data, when we are taking 100% data, and when we have to understand the module, you can say model, we take generally 70% part to training part, to basically learn that model, what we are doing, and 30% part will be the testing part. So suppose in the 30% testing, or you can say in the 70% training data, if we get the same answer, something like in the testing data, like 30% in 30 in the in testing set, all the data that is present in the testing set will be already present in the, you can say, training set. That will, it is overfitting, because the answer is already known to the model. It is not learning in that way, right? Suppose what I mean to say is, let me give you more better understanding. So suppose this is Asmi, semester is 3, this is true. Suppose same thing, this is, I'm talking about the training part, training set basically, okay. Now same thing, if same thing is present in my testing set also, like ASME, third semester, and what will be my is it a TFUG member or not? Suppose this is the, maybe we have to test it out. So obviously this thing is present in training set, it will give the answer. We are not doing machine learning here, we are doing classical computing, where we are already give you 2 plus 2 equal to 4, and then we are asking what is meaning of 2 plus 2. Obviously it will 4 only, right? That's a major thing came into here. So that's a sometime when you're training your model, there's a high possibility you get 100% accuracy. That is not possible. That is not possible, right? Because the thing is, you're basically you're giving the answer already in the training part, and when you are asking the same question in testing, it is just like you go for a Monday test, and a day before your teacher are basically giving you like this question will be guaranteed in your Monday test or any test that you are giving, right? You will already basically you can say you already learn that question or like particular answer basically, and if it comes there, if that comes in the exam, you obviously know that particular answer, because you're, even though you didn't know what is the meaning of that question and all, but you basically remembered that answer, right? And you will basically spell out on the paper. That's what here happening is. When we say that paper is going on the that paper that you did for the testing part, you say it's, I know all the answer, but you didn't understand at all because you just written it like in your brain. You are not learning it basically, right? That's the same thing happening here. So when we say model performance, that's a major thing that we came around it, how we can improve it in that sense basically. So that's the first thing. Understand your data. That's an important thing. Suppose you are like same thing, you can do it on your MongoDB, you can say. Let me give you more instance. If you got to give you a better understanding, give me a moment. Is there anyone by any chance who did who used MongoDB, you can say MongoDB Atlas by any chance while building any project? Let me know first of all in the chat section if possible. Is there anyone who did MongoDB before by any chance, or used Atlas, MongoDB Compass Atlas by any chance? You can write down in the chat if possible, that will be better. Okay, and a collector saying no. Okay. Okay, cool. I will show you one thing, and I hope so. Even though it's a machine learning session, I kind of give you some database knowledge also on assignment, how you can use MongoDB Campus Atlas basically. Okay. So just give me a moment. Let me open my MongoDB then. Just give me a moment. Just give me a moment. Let me reshare my screen then. Just give me a moment. I guess it's opening. Just give me a moment, folks. Till then, till now, there is any doubts? Is there any doubts till now? Whatever I explained till now, let me know that. Cool, cool. Okay, cool. Give me a moment. Let my MongoDB open. I didn't know why it's taking so much time. Open my MongoDB. Let me refresh it. Okay, let me do one thing. Let me share my normal screen. As MongoDB will open, I will basically explain you that also. Okay, so that will be better to give you. I hope so. My screen is visible to all of you. Let me know, is it visible or not? I hope so it's visible to all of you, and my voice is also not breaking. I'm hoping that. So yeah, cool then. Let's go in depth part of it. Okay. So I will explain you about more about overfitting and underfitting part basically. So let's go down. Okay. So when we say, you can say, when we're talking about overfitting and underfitting, let me give you more instances around it. Suppose, I hope so, my compass is up, and I guess it's open at 2 thing, but so sorry for that. I'm testing. Okay, so let me, what I can do, let me, yeah, I can give you more or less, just give me a moment. Okay, let me know my MongoDB thing is open at your space or not. Just give me, tell me about it. Okay, cool, great. So basically, what it's a basically you can basically download it from MongoDB website basically. Okay, so if you will go, yeah, I basically open my old you can say old database basically, which I'm recently working around it. Okay, let me open it. Okay, so this is the thing I already doing with something basically. Okay, so okay, let me give you a better understanding around the thing. Okay, so these are the, you can say these are the tables under a database called core selling, yeah, test basically test data set, you can understand in that way. Okay, so if I go to the admin part basically for now, so this is a basically body type like which contain id, username, password, and the version of that thing. Okay, basically you can add something if you want, you can add one more thing, add a field with basically something like that if you want, something like that. Okay, so this is all thing in JSON format. Okay, this is the all thing you can say in the JSON format. Can I give you a better okay, so this is kind of a schema. You can schema basically nothing else. What are the fields that is in your table? That's we called in a database called schema basically, and how the data, when we say schema or database, just to understand, database is obviously a space where you can store your data, and schema is like how you're storing your data, how you're structuring your data. That's what a basic thing, and that is very required, because when we say unstructured data, we can't able to like basically run or more train anything. So understanding your data is very important. And suppose for now, if you will see here, like let me go to the maybe this part. This is the basically my core section. Like I created one like just a random thing. If you will see here, automatic generating ID, which is very unique to this space. Okay, your title, your description, and in these all these things, I have to first of all check what is my fund. That is the most priority thing. For here, title will be my most important feature, right? On which part I have to analyze my data. That's a major important thing here, right? Cool. And again, for different things, that maybe if I give you a description, maybe that model can help you understand more, because this is a, maybe this is a song basically. Okay, but what is this about, actually telling about it basically, more information around. Okay, now the major thing, let me reshare my screen. Let me change my window and go here. Okay, so let me give you more major understanding. So suppose if there is some data. Okay, and not in that sense. Maybe let me love it. And maybe something like this, and all the data are overlapping very good. That is, maybe this is kind of x square function, so you can say w1 x1 square plus w2 x2 square, something like this you can say, or maybe not square, maybe just, and w3. This is a kind of function, f of x function. Suppose this is the kind of function which actually balancing out here. But my overall thing came into thing, like when it fits the training set at very extreme, like, or extreme values also. Here the came called variance came here. So what is the meaning of variance actually? Just to give you more glimpse around it. Variance is more like to understand, give you more. Okay, so first of all, understand if it is just give me, I will give you more. If it is high variance, suppose it's a high variance, that means it's overfit basically. And if it is high base, high bias, so it is under. Now, what is the meaning of both the things? I will explain you that. So let's go with the thing with bias first of all. Okay. So let me make it over here. Okay. So just understand, bias refers to the error introduced by approximating a real life problem with a simplified model. So it occurs when the model is too simple to capture the underlying structure of data. And high bias can lead to underfitting because where the model fails to capture the pattern in the training data and performs poorly on both the training and test base basically, because you have very less data. It created a lot of bias basically. Generally when we say in a gradient descent also, right, like maybe w1x, yeah, wx3, this bias if is higher, that means we have a less of data. Obviously if it is less, that means we have to basically add some bias to maintain that function, right, f of x. That's a major thing around it, right? And when we say variance, so variance basically it seems like it refers to the model sensitivity to small fluctuation in training data. It occurs where the model is too complex. Suppose, as I already explained you in the earlier part, maybe like this is, right, so this is very complex data, and when we say how we can basically fit that data, right, so right, this is very complex data, but this activation function is not, you're not able to generalize it basically, right? So high variance can lead to overfitting where the model performs well on the training data but fails to generalize the unseen data basically. Suppose there's some random, like this is a part of something, but there's some, you can say, let me change the color of it, there is some other data present over it, right? Like suppose this is a star I'm making, and basically it is doing, it is only generalizing this part, not this part. That's where variance fails. So the meaning of it, there is not too high variance also and not too high base. If we can maintain that, that's what makes a good model basically. Balancing the bias and variance is called bias variance trade-off basically. That's the basic thing. When we say, when we're balancing of, that's when the variance and bias trade-off came into play. Okay. And this is to, like, to get more training data feature, like is, if I will explain that thing in Hindi, the feature ज़्यादा हो जाए but insufficient data हो, तभी overfit होता है basically, overfit करेगा वो, ठीक है? Features बहुत, like this, you have a lot of, like, what is the meaning of it, like this, you have lot of parameters. x2 ये जा रहा है मान लो w and xn तक, right? You have a lot of features, but the thing is data is very less. Suppose there is, so collect the major thing is collect more data, and that's why feature engineering came into play, right? Why feature engineering is the thing. You have a lot of feature, but you have to decide which feature have to go with it. That's a major thing. And reduce a parameter. That is parameter when I'm saying W1, W2. These are the parameters, or you can say at the last bias. These are the parameters to it, basically. Okay. So if I go with the intuition around it, how what you can do with it. So suppose there's a function wx1 plus w2x square plus w cube x cube plus w4 x4 plus p. Let's make it 0. जिसके ज्यादा पावर वाले उनको 0 कर दो. Why? Because w become really small. क्योंकि अगर x का वैल्यू बढ़ेगा तो ये obviously small होंगे. That's a simple thing it is basically. So make w3 really small. So that's why the regularization came into play. What is the meaning of regularization? And suppose you have a lot of data. Suppose you have a neural network. This is the neural network. ये hidden layers हैं, and you are getting something like this, and you are getting. तो dropout basically मतलब है इनको एक को हटा देना है, इनमें से एक को drop out कर देना basically, which basically you are reducing the parameters, right? That's a major thing. But obviously you get a lack of data around it because you are dropping that thing, basically regularization part basically. Okay. So this is what I wanted to share with you all. Choosing feature, that's a really important, and how you're basically understanding that part basically. Okay. If I will let me re-switch the thing with another this part. Okay, so if you see here, we have a lot of columns, but to decide which feature is important, all the 4 to 5 parameters are features: ID, title, description, price. But understand what are the main goal behind it, what we have to do with it, right? For now, we have to do majorly focuses on the maybe to get the title, like to get the course name basically. That's what the main take. So we will go with the title or description part basically to understand. Other thing is not important as of now when we're going with the searching concept, right? When we are searching around, that's what the major thing. And this is the whole session majorly around it, about how you are basically deciding the major thing and how you're going with that thing, right? Cool. Still you're facing any like what I shared till now, you get it or not? Just let me know that. Stop sharing for now. Is it something that you didn't get? Tell me no. Because this is a very theoretical thing, but to understand that kind of thing, that's really important. How you're understanding your model, or to give you more better glimpse, let me do. Yeah, that's a concept, because the thing is, if I explain it from very mathematical, like if I explain from code, you're not able to understand it because I have to tweak the parameters. It's more like a boring thing. Like that's why like this whole session is very theoretical around it. But if you get the basics clear, that's a major focus, right? Let me give you more better understanding. Give me a moment. Let me give you more better understanding to it. Let me share my slide with you all. Give me a moment. Okay, so let me screen share with you. And this is also theoretical, but I give you a more better, like I did this a lot earlier basically. Okay, so majorly thing is like When we say model optimization, can be came under the umbrella reducing the model size, speeding up the inference time, reducing the power used to run a model. So why should we care about it? Your world class but heavy models are like not suitable for deployment. That's a major thing that we are really focuses on. Okay, when you are building any model around it, so this is also, you have to obviously deploy that model, right? It is just not for your own sake. You have to create some business out of it, right? You have to use in the production, right? So consider deploying a model to Raspberry Pi or maybe mobile phones or microcontroller. Moreover, heavier model tends to have a latency, right? And just give you more instance, if you have a less latency, that model will work really great. That's the major focus behind it. Okay. Latency during serving is not suitable for critical application. Heavier the model can affect the infrastructure cost efficiently, because the thing is it takes a lot of computation power to it. What if cloud-based model hosting is not an option? Right? That's a major thing behind it. So different areas for a model to optimize. So you can reduce the numerical precision, right? Are all the operation of model graph needed during the inference? So why I'm sharing all these things basically to give you understand. Just basically adding some of the layers in the model doesn't make you a great machine learning engineer. You have to understand what is your goal to it. That's a major focus area behind it. Okay. And to give you more better, so when we say mapping area to optimization techniques, I'm not going into this part, but just give you a major thing, like this is the thing. Okay. Understand this code. You want code, right? So let me share that code with you. Even though you're not able to understand it, but just giving you a basic glimpse around. So let me use my pointer here. Okay. So if you will see this part, right? Sorry. Okay. So if you will see this part, like we have two X and Y. Basically, I am adding a dense layer around it. Unit one, we are doing a very single perceptron kind of thing, basically. And we basically compile with the optimizer called stochastic gradient descent. You pretty much know we are using a loss function called mean square error. Basically, I'm doing a model fit, okay, with 50 epochs. The major thing come around how we can optimize this model. We are using TF Lite here, basically, just to basically for the Raspberry Pi or mobile devices. Okay. Now, when we fit.expect these epochs numbers also depend on thing. How much 50, how much train a lot, like epoch to consider more like a loop, basically. How many time it rerun around it and understanding the whole learning model around it. Okay. So this is the thing that you wanted to understand. Why it can't be 20 epoch, why it should be 50, or why it should be not not too or not too much. Because if you learn a lot of things for the model, so there is a high possibility maybe not able to understand that answer, because if you get all the answer around it, it's just like a chatbot. It is not learning all the answer. You created a knowledge graph around it. But the thing is, if anything come out of that particular knowledge graph, not able to answer it, he will say, basically that model will say, basically, I didn't know, and it is not in my database, something. So we are not wanting to do that, right? We have to make that model so it can learn properly. That's a major focus behind it. I hope so you got it. Like, even it was theoretical. For the next part, which is properly demo kind of thing, I hope so you will understand that part, how I am doing it, and something like this, basically. Okay. I hope so you got it, Galactus. Cool. I hope so. There's no more question. Afzal, is there any question on the YouTube side? Let me know. Otherwise, we can basically, yeah. Cool. Great. Okay, so that PPT is of, I can't share that thing for really sorry, Galactus, because that slide is with the Google team actually. I have a GD, so I have access to that, but I can't share that PPT. So really sorry for that. Really sorry. Yeah. Okay, great. That is great. If you wanted to like come on the stage, it's also possible. There is not a problem. Until then, Afzal, you can stop the stream also. Yeah. Okay, great. Yeah, that's what the main take around it, and why I'm wanted